So in the third example, we're going to have a unique situation where the IC is going to be infinity. And what we can see here is a crank DC of the mechanism rotate at a constant rate of 6 radians per second. So the link DC have the omega of 6 radians per second. We need to know what will be the speed at the point A. Now let's analyze that. If this one is going to go up in that direction to the anti-clockwise, it will lift this link up. Okay, this one is going to have an arc movement, but at this instant we are going to have the velocity c, which will be perpendicular to it. At the same time, this will also going to go with an angular movement, okay, in that direction. Okay, and this one is also going to go in angular movement. We have to know that the so that this one is going to be connected here. The velocities are going to be different, but I mean between B and A, but the omega is going to be the same. So we only need to find the omega of the link BE, which is going to be the same omega as we have on the EA. And then we're going to be able to calculate the velocity at the point A at this instant, which is going to be perpendicular, which is going to be equal to the radius EA and multiplied by the omega of the link BE or the EA, which is going to be the same. So we start from here and start to find the solution. First, what we can do is that we can find this velocity very easy. Because if I'm going to take the length DC alone, okay, there's the DC link. And that's the, sorry, not R, and does have the omega. It have an R value of 1 meter. So I can find that the VC is equal to the omega value multiplied by the R. The R is 1, the omega is 6, so it's going to be 6 meters per second is the velocity we're going to have at that point. Okay, so we're going to follow the procedure and try to find the answer for that. Okay, so next. So by inspection, as you can see here, just let me get rid of that. Okay, by inspection, the DC and the AB are going to be subjected to the motion around the fixed axis, as you can see here. And the velocity c is going to be the omega CD multiplied by the radius CD, which is equal to 1. So we can simply find that the velocity is going to be equal to 6 meters per second. Okay. Now, note that the B point is going to follow a circular path about the pin E, as I told you earlier, is going to have this circular path here. And therefore, the velocity B is also going to be a vertical in that case. It's going to be perpendicular to the link BE. The IC of these two velocities, if you try to sketch them, okay, let's say you're going to make a line in this direction, a line in this direction, these lines never going to be able to intersect, because in that instance it's going to be parallel never intersect. Thus we are going to say that the omega BC in that case is going to be equal to 0 if I'll try to write down the relative velocity equation, and the VB is going to be equal to the VC, which is we found earlier as 6 meters per second. Now this 6 meters per second of the VB is going to be equal to the omega of the BE multiplied by the RVE, which is 2. So now I can rearrange this equation to find the value of the omega BE. So the omega BE in that case is going to be equal to the VB multiplied by the REB. The REB is 2, the velocity B is 6, so I can find that the omega BA is going to be equal to 3 radians per second. That's it. The velocity A is equal to, as we mentioned earlier, the omega BA, which is equal to the omega of the EA. BE, which is equal to the omega EA, which is 3, multiplied by the distance from E to A, which is 1 meter. And thus I will find that this velocity is going to be equal to 3 meters per second. That's it. That's the answer for this question. Okay, thank you very much.